Well, good afternoon, everyone. Thanks for coming. And yeah, today we're going to talk about music. Plato, an ancient Greek philosopher and mathematician, once said, "Music is moral law. It gives soul to the universe, wings to the mind, flight to the imagination, and charm and gaiety to everything and life." We all know the power and influence of music and how it can influence people from all walks of life. Hi. Ta-da. Hi, I'm Abhishek, and today we're going to take a glimpse into the future of music discovery. Before I go into the details, let me tell you how I came up with the idea of this, So I was taking an exchange course in Athens last year. So this was in Madrid with a couple of my friends from TU Delft. And during the course, this is last November, and the Apple Watch was released around September of last year. Well, not released, announced rather. And one of the evenings with my dorm mates, I was talking, and like, when geeks usually get up, we talk about technology. That's all we do. So we're talking, and we're like, okay, what can you do with an Apple Watch that you can't do with a smartphone already? It has an accelerometer. It was speculated to have a gyroscope, GPS, but most interestingly, it would also have a pulse sensor to collect our own heartbeat. So we said, okay. We kept talking back and forth, and we realized, okay, maybe we can do something with music, heartbeat, music, possible. Okay. It didn't really click so much then. I came back to Delft, and one of the days I was working out at the gym, and I was changing my music with my sweaty hands, and as I was changing it, okay, it's the same music that I have from SoundCloud, and I'm changing it, and then I don't remember how the workout went. I don't know, but I wanted to get new music to motivate me. On the ride back home, I was thinking, wait a second. If we have a smartphone in our pocket that has everything, that has a gyroscope, you can get weather information, location, accelerometer, compass, why can we not use that to understand the situation that we're in and use that information to recommend music? Why is that so difficult? And that's when it started hitting me, like, yeah, definitely we can. So to formalize this, I had to come up with a research question. So the goal of this thesis, the main research question is, can novel music be recommended from contextual situations that have been inferred from sensory data? Is that possible? Okay. With that, I started. So let me talk a little bit about the outline. I named the system ImpliciTunes. Well, implicit because I don't want the user to have any explicit interaction. I want music to just be recommended to him or her. And tunes because, well, it's music, so tunes. So a brief look at the outline. We're first going to take out the current challenges that systems have, that current music recommenders have. After that, we'll take a look at, from these challenges, how do we get some design principles to guide our design process. We follow that up with our proposed system, and we'll take a look at how we evaluated the system, and finally, we'll look at future work. So, current challenges. Before we look at the challenges, I want to say that there are two main approaches in research in terms of music recommendation. The first one is content-based. Content-based refers to things like you look at the song's genre or the audio characteristics like tempo, etc. And it looks at what the user has done in the past. So as an example, if user A has listened to Jay-Z, the system will then find an artist similar to Jay-Z, so in this case Kanye West, and Kanye West will then be recommended to user A. So it's looking at similar artists. The second approach is collaborative filtering. In this, we look at the users, the taste similarities between users to help recommend music. So here we have user A. He listens to Kanye West as well. But user A and B have similar music tastes. They both listen to the same kind of music. And the system will also then recommend Kanye West to the second user. In practice, what we see with most services is, if you see Spotify, Pandora, Apple Music, they will basically use a combination of these two approaches or these individually to recommend music. We think there are some challenges with these two systems for future improvement. The first one that we've identified is the filter bubble. It is a term that was coined by Eli Pariser. He's an internet activist, and it basically talks about how when we enter a music system, let's say we start as an individual, you, and you have all these different genres of music that you hope to discover. That's the hope. But what ends up happening is that we end up creating a bubble around ourselves. Because we're looking so much at the past, we end up listening to the same kind of music, whether it's, let's say you like listening to a lot of rock music. You'll narrow yourself down further and further into these fields. And for you to break out of that bubble, it becomes increasingly difficult as you start using the system more and more. And that's a big problem that we've identified for these two approaches that we told you. The second challenge is, for those of you familiar with recommender systems, you would know, but for those who don't, cold start refers to the problem that's there anytime a new user enters a system. They have no past history, so you have no ratings to go by. So the first recommendations that you can give to a user is quite difficult for the system to do because you have no history to start with. And that is true with new songs going into the system, and also if it's a new context. If you're in a new situation, what do? It's not just limited to content-based or collaborative filtering. So that's the second challenge that we've identified. Thirdly, with all this music that's available out there, you have YouTube, you have Spotify, Apple Music, etc. It's still tedious for us to keep updating our music tastes. It takes some effort to build playlists, download songs, or create offline playlists, etc. And we want to have, we want to get rid of this. We want to avoid this. And that's the third challenge that we've identified. We looked at these three, we said, in our system, we don't want to have these, and we want to address them. First thing is streaming music. About 75% of people listen to music online. This was a recent study conducted by Nielsen in the States, and they interviewed about 3,000 participants. And this is in a week, so they say about 75% of the time you listen to music online. Okay, so we want to definitely focus our algorithm or our system on streaming music. Secondly, we want to be able to understand from sensors our environment. We want the system to know what our surrounding is and then use that information to recommend music to us. So we want to be context aware. Thirdly and fourth, these are sort of related, we want to focus on music discovery. The goal is not to recreate what your playlist is. That's not the goal. So that's sort of like the scope boundaries that we have. We want to expand your music horizon. And for that, we want to make sure that we're not learning from your past history. We don't want to start on day one saying, okay, you've listened to this 6 months ago, so we want to have that as an input to the system. We don't want to have that. So that makes it a little bit more challenging, but interesting. So we want to have this learning free. With these four in mind, with these four design principles, and the most important one was user experience. Because that really makes or breaks a system. If you think about an application that we download today, the most critical moments after you download is the first 2 or 3 minutes. That's when you decide if you're going to keep the app or if you're going to delete it. So if in those critical moments, if the system is not good enough to recommend you good music, or, well, in this case it's music, the user will just delete it, regardless of how much better the system gets 5 days from now. So it makes no sense. And also it has to be easy to use, it has to be responsive enough. So user experience should tie everything in to the system. Okay, so this is sort of the timeline of when I started and today. You can have, I think I've interacted with a lot of people on one of these events over here, from identification of music source to the focus group to user evaluation, and this is sort of splitting up exact dates, how we went about the process. So we talked about the system. Let's take a look at what it does. You're going to see an AirPlay of my phone, and hopefully the speakers still work so you can listen to some music. So this is the app. this is a trial application, that's why there's a logo, so just keep that in mind. You know what, let me start it from scratch so you get the... So, as you can see, the application, this is the main interface, we call it. What we wanted to give our users is they want to get in the system and start listening to music immediately, not wait and not have it to learn. So this main screen that we have, it's going to create playlists based on the situation that the user is in. And as and when we go about our day, we will get different playlists that get curated and they show up. And we can pull it down for refresh. The three tabs at the bottom. So it recognizes I was at the university, and so it says, okay, working or relaxing. So it knows this is running on my phone right now. So the second tab is the favorites tab. We give the user a choice of either looking at the SoundCloud favorites. This is all of my likes from SoundCloud. Or we also give them a choice of saving it offline on their phone if and when they choose not to use SoundCloud. And thirdly is we give the user some choices. Minimal controls. We ask them, okay, tell me about your music preferences. But we ask them, what do you not want to listen to? That's different than what most other applications will ask you. Okay, tell me what you want to listen to. We ask our users, tell me what you don't want to listen to. And we're not going to use that for the recommendation. We're going to make sure that anytime a song comes in that you don't want to listen to, we want to filter that out. And so this is all the genres that we'll ask the users, okay, and they can set it. And lastly, we'll say, okay, we call this thing the blacklist period. That's like, if you get a song that you don't like, don't play it for me for the next 5, 15, or 30 days. We call that a blacklist. And you can set how long you want it for. So let's listen to some music. Okay, so let's say, start listening to some music. And this is something that I have no idea what this music is, so I took a chance, eh? Again, this is working music, so you're imagining working on your laptop. And you can see we give the user some controls. The blacklist over here, and behind the trial there's a favorite icon, there's a heart icon, and minimum play, pause, next. So the next song. I don't like this one. And if you blacklist it, it stops it, it goes to the next song. It thinks I'm in an exam, okay, alright. And next song. If you go back, you can always get access to it again. So you have the now playing playlist. So if you tap on it again, you see the playlist. This is new music that you would not have otherwise listened to. That's the whole point of this. And if you like it, so if I say I like this, it will get added to my favorites in here. In this case, it will be added to my SoundCloud favorites too, because it's linked. And as we go about our day, we'll get different play. If you're at the gym or if you're working out, you will get an exercising playlist. I can't show it right now because I'm not at the gym. So that was the application demo. So let's see how it works now. Okay. I just want to turn off hotspot, else my data will run out in 2 seconds. All right. Okay. So, you saw the system, how it works. And now let's see, well, you saw the system working. Now you'll see how it works. So, we'll go through each one of these sections individually. We have 4 main sections. So, we have the sensors, we have the context modeling section, we have the music retrieval and analysis, and finally the recommendation. 4 blocks. So let's start with the sensors. These are the sensors that we focus on today. Location, weather, compass, date, time, motion. We named this motion, but it's more the icon for an accelerometer. And tempo and light sensor. Before these go into the context modeling part, we have to do some pre-processing. These need to, because there's a lot of noisy data. For example, the light sensor and the compass, they are used in tandem to determine if you're inside or outside. Why is that important? Well, if you're commuting, we can just rely on the fact that if you're outside and inside, and that's enough. Because GPS doesn't make sense if you're outside, because we have to geocode it back to a location. But if you're moving, it doesn't make sense to give it an address. So all we need is if you're inside or outside. That's one example of where we use compass and the light sensor. And all these other sensors, they're coming in at random times. We're not checking these sensor data at constant intervals. So they're coming in as and when you're moving around the day. They go into the system, into the fuzzy logic context modeling. What is this? We call this the brain of the system. This is where we understand the situation of the user. So, I'll walk you through this. It looks like a lot of information, but that block that you saw, fuzzy logic, it's internally divided into 4 mini blocks. And these are all the sensor data inputs coming in. So for example, you have, to determine indoor, outdoor, we take in inputs from those 5. So you have device movement, magnetic variance, day-night brightness, and device connectivity. They go in to the system, and you also get the location, which in turn becomes the place. Because location, we call it as the raw GPS coordinates, latitude, longitude. As soon as you geocode it to an address, so if it's a bar, if it's a restaurant, or if it's a school, that becomes a place in our system. It goes into the situational logic block, and what you get out is one of these 7 situations that we've chosen to focus on for this thesis. Waking up, commuting, working, relaxing, exercising, housework, and sleeping. That's what we decide to focus on. The second block, there is an aspect of mood and music. Yeah? If in my thesis I've written, there is a different connection between music and mood and vice versa. But it's very difficult to tell the user what is their mood. So we said, you know what, and also if you get that wrong, someone might take it personally and say, oh, you're angry. No, I'm not angry. So we don't want to have that. So we said, okay, let's look at something that is universally affecting users in a given geographical area. So we said, okay, weather information. So air pressure, humidity, sunshine, and temperature. These 4 psychology studies have shown that they have an impact on our mood. So, okay, so this logic ends up giving us valence and arousal. Valence tells us how pleasant or how unpleasant a song is. And arousal is how excited or unexciting a song is. With these, we can come up with 4 moods: happy, angry, sad, or calm. And that's all we want to know. As we go around our day, we'll get one of these 7 or more, and we'll get one for sure, the mood one, because it's always there, these playlists. So sensors come in, situations go out. That's how the system works. One example. So what's going on inside the situational block? So let's say if the activity is walking and the day of week is weekday, and you can read it, we eventually decide the context is commuting. Now that is not the only case where the context will be commuting. There are other cases where context can also be commuting. What fuzzy logic allows us to do is that it allows us to take wake data and allows us to create rules that will be able to handle different situations. So just because I'm here, it might not only mean that I'm working. It could mean also something else. Fuzzy logic allows us to create these rules and gives us the flexibility to also address different situations, different possibilities for the same inputs. And that makes the system very flexible and very scalable in that sense. So once the outputs come in, exit the system, we need now know the context. Once you know the context, we need music for that context. So that's where we go to SoundCloud. SoundCloud is our music source. And to retrieve relevant contextual music, we use tags. Now these tags have been harvested from Last.fm. I don't know if you guys know, it's a music service that people can add their own tags to music. And these tags are not necessarily just the artist, they can also be the situation, the event, the activity that the person is doing at the time of listening to that song. So for example, if the context was commuting, we harvested some tags. Here's some examples of use. Driving, progressive, groovy, road trip. We're going to use these to retrieve relevant music from SoundCloud. Once we get relevant music for these tags, each and every song then goes to EchoNest. What is EchoNest? EchoNest is, if you remember, we talked about content-based filtering. This is where we look at this, the sound characteristics. So tempo, valence, arousal, energy, etc. They do content analysis. So we send these songs, the URL for the song, to EchoNest, and EchoNest then processes this and comes back with a summary of, okay, this song has 120 BPM, it has an energy level of blah, 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 etc. And we get this information for each and every song. And once we get the information for every song back, for every playlist, this is where we come into the recommendation block. What is this recommendation block doing? It is taking in, so it's looking at what the context is. So if you're exercising, it knows the playlist that was filtered down from SoundCloud now to EchoNest, and now you have a filtered down playlist. And now we'll say, okay, if you're exercising, we want to set a threshold for the tempo. The tempo should be at least, let's say, 120 BPM. So that post-processing happens because of the EchoNest analysis in our system. Eventually, what comes out to the user are these playlists that you saw in the demo. So the user, all they see is this. With all the sensor data that was going on in the background, this is what the user sees. All they have to do is just pick one of these playlists, depending on their situation, and they start listening to music. And the key thing to remember over here is that this is not music that they would have probably listened to in the past. We're trying to expand them out, get to listen to as much new music as possible. And mood is, just to clarify, mood is the one we talk about, the atmospheric playlist. So from weather to mood. That's how we call it, the mood playlist. So, okay, we have the system, we went through the demo, everything, so the system needs evaluation. So, this is where it was evaluated. Testers were from these locations. 22 testers, 10 days. They had a live testing. So, we didn't tell users, okay, do this, don't do that. We just said, test it. Listen to music and open the application. To collect feedback from them, we didn't tell them, okay, send us the logs. The logs were collected automatically in the background, so we could see it on our server. And at the end of the survey, at the end of the testing period, we got some, we had an exit survey, so we got some survey data from that. So that was really good qualitative feedback that we got. So, final stats. 22 users between those time dates, and this application was for 5S, 6 and 6 Plus only. The reason was the iPhones 5S, 6 and 6 Plus have a special motion chip. What it does is it allows you to get a filtered down state of the activity. So if you're walking, stationary, running, driving, etc. So it gives you a filtered state. If I had to build it also for iPhone 4S and iPhone 4 or 5 for that matter, I'd have to do my own activity recognition, and that I left as outside the scope of this thesis. But yeah, 1,300 playlists were recommended, about 32,000 songs were recommended, so about approximately 25 songs per playlist. Users played 1,200 unique songs over the course of 10 days, and of those, 203 songs were blacklisted. They did not like. They added it to their "Don't ever play it to me again" list. And of the 1,200, 49 songs were favorited. There was an issue with the software initially for the first half where adding it to favorites was an issue. So we think this number could have been higher, but because users couldn't really log in, there was a bug in the code. So we think this number could have been higher. But unfortunately, this was working, so they kept blacklisting. So yeah, this is the overall stats. Now, the first research, we know the overall research question was, can novel music be recommended based on contextual situations? We split that up into three sub-questions. The first one is, what information shown on the user interface conveys a sense of context to the user? They gave users these 3 screenshots. The main purpose of this question was, we are taking an abstract concept as sensors and giving it to users in a form that hopefully they understand. That was the main purpose of this question. I mean, you can look at it just from the user interface point of view, but it's taking a concept as sensors and giving it to users. Okay, this is the playlist that was used to generate for this situation. First one, as you can see, we gave images and tags. These are the contexts. The second one, we gave them just images. And third one, just we said, okay, what if you just use colors? Can you determine, this is the context? And what we got as a result is 90% of the participants preferred this one because they could really connect the tags to this picture. And this, okay, yeah, maybe not the clown, because we got some feedback by the clown. Okay, it doesn't make sense. That was in the user feedback. But the relaxing and housework, it was all the other ones exercising. Okay, yeah, tag plus image made sense. Okay, second research question. Which playlist type? There were two types of playlists, right? One was, the first one was the situational playlist. We had the 7 situations. And the second one was the atmospheric-based playlist, which is the weather to mood. Which one did they prefer? For this, we looked at the user logs that we collected from the user's devices over the course of 10 days. And from that data, what we saw is that 44% of the time people listen to the mood playlist. Now, why? Our reasoning for this is the mood playlist was always there on the user interface. Why? Because it was the playlist that was constant, because it's the weather information. As opposed to the situational playlist that kept changing because the user moved around. So we know that the user listened to this playlist the most because this was always there for the user to listen to. And second was relaxing, and third was working. Working and then relaxing. And this is how they listen to the music. So based on this, we asked them, which one did you prefer listening to? And this was coming from the survey, not from the user data, obviously. And we made a comparison between what they did and what they said. Did it match up? It did match up. And so situational playlists, they said they preferred listening to more. Our understanding is that, also from the feedback that we got, is users like the diversity in the recommendations when they saw a lot more playlists, as opposed to the mood playlist, which was always there. So yeah, they definitely preferred the situational playlists. Third question that we asked is content-based song re-ranking. This is the Echo Nest block that does the song analysis for valence and arousal, etc. Is that important, relevant for music recommendations? Well, from 32,000 songs, we had about 8,000 that went for analysis. Why that difference? Well, every song, when it's analyzed, it takes about 30 seconds to a minute almost to analyze, depending on the length of the song. So we said that in order to have a better user experience, we want the user to have at least 2 playlists before we send any new songs for recommendation to Echo Nest. Otherwise, it will just take too long for one playlist. If you think of 30 songs, each song takes 30 seconds, that's 900 seconds. She said no. Let the user have at least 2 playlists, and if a third playlist comes up, then we'll do content-based analysis. That's why we only sent 8,000 of the 32,000 for analysis. But however, Echo Nest, because we were using an educational license, so we had a limit on how many API calls we can make per minute. So we were capped at 60 API calls per minute. After that, Echo Nest would just return an error. And we knew that limitation going in. It's not something we found out just during evaluation. So that's why only 14% of the 8,600 were actually analyzed, even though we gave it 8,600. So we didn't, so that's one of the limitations that we saw from the logs. What we asked users to answer this question is we gave them playlists. Okay, imagine you have this relaxing playlist for your situation. The songs that are highlighted in the yellow boxes, those are the songs that the system will remove based on what it thinks is best for the situation. That's what we told. Are you happy? Are you pleased or displeased with this decision from the system? That's what we asked. So just we told it, this is the playlist. Imagine these songs were removed by the system. Does that make sense for you? Well, you can see the results 46% said they'd be pleased, and 38 were, I don't know, it doesn't matter to me. One key, one interesting observation over here was that some users didn't understand the question, so we think we could have worded that better. Secondly, this is only one of the 3 questions that we think could be answered better in future. We didn't get clear data for this. But one thing we got for sure, that users told us that they were happy that the system was trying to understand their situation and filter out songs based on that. That's something that we got from the qualitative data. And yeah. So, we had the 3 research questions. On top of that, we got a lot of qualitative feedback from the survey. One of the cons of the system that users told us is sometimes the relevancy of the music recommendation wasn't that great. It pushed us too far out from what we usually listen to. We knew this was going to happen because we did not take any previous experience, any history into account. That's one of the cons that they told us. Okay. Second one was that, okay, there weren't enough playlist choices. We would like to see more playlists come up in the original list. And lastly, the music dislike preferences did not always take effect. Even though you said, okay, I don't like listening to trance music, it did not take effect immediately. So that's one of the complaints that users told us. Okay? We had a lot more feedback, but these are the most important ones that we sort of figured out. On the pros side, they loved the interface. It was very simple and easy to use. No complications, no login. You see the playlist tab, start listening to music. No, yeah. And also the auto curation of playlist based on situation, they appreciated the fact that I didn't have to go out of my way to find new music. I just had it depending on the situation that I was in. And lastly, it definitely pushed them outside the music what they typically listen to. So these are some of the top level feedbacks. And lastly, we asked the users. We told them, okay, after the test period ends, let us know if you want to continue using the application or not. I could see from the logs that a lot of them kept using it. So I was happy with that. And yeah, so I could see quite a few of them continuing to listen to the application, and I hope discovering new music. So we had the conclusions from the results, and we don't think of it as an end to the thesis. We think of it as this is just a beginning in terms of doing something with this in future, because there's a lot of potential with this. And instead of putting a future work just from the research side, we said, okay, it's also interesting how we can relate this, what users told us, what research we want to do. And did they match up? So, users told us, okay, we want reduced song skipping. We don't want to skip too many songs. Okay. And research and the thesis that we sort of said that, okay, we can have dynamic tag selection. Today we have a sort of 15 tags per context, and based on those we randomly choose 5 to give the user the level of diversity per context. So like we saw for commuting, we said driving, progressive, road trip. We want to make that dynamically change over time. So that adds more diversity for that context. And same thing, we can also look at in future user-created playlists, because a lot of people have their own playlists. If it's chill music, if it's party music, can we tap into that as well? These are curated stuff. So that's from users to research. It makes a link there. Secondly, a lot of users, well, almost all users said, we want to know more explanation. How did you come up with this playlist? So we think that the images and the tags were not enough. They want to see more. And that's one area of research that we think can be done. And that's why improving the user interface to convey a sense of context to users, beyond images and beyond tags. And also images, today it was not the focus of the thesis to pick the right images for the context. That we said, okay, we saw some images that was again, my personal thing, okay, makes sense, exercising, dumbbells, okay, put that in. But if you think that it can be a different area of research too, if you can find relevant images for the context. And tags, we had another feedback from tags coming in where, don't just tell me I'm working, give me something more fun. Or let's say, on the weekend, we just say right now relaxing. Or they want something more, it's like, okay, chilling, Sunday lounge or Sunday chill. just the name of the playlist. That's something that can be improved upon in future as well. And lastly, like we already talked about, more playlist choices. We've been completely averse to learning anything from the user's past history for their music taste. But one place where we can learn is the user's contextual history, what they're doing. Why? Why we want to do that is